working.
Oh, that is definitely cheated, totally. All right, so we're gonna talk about operations on functions again. And this time I actually have slides. So given f of x is root x plus 4 and g of x is root 3 minus x, find the following functions and their domains. So finding f plus g is not the hard part. The hard part is getting the domains. So first of all, what would f plus g be? Plus root 3 minus x. There's no algebra you can do to combine those. That's it, you're done. That's as simple as it's going to get. And then for a number to work in the function f plus g, it has to work in both pieces. So you've got to find the domains of f and g and intersect them. So how would you find the domain of f? What would you set bigger than or equal to 0? X plus 4 must be bigger than or equal to 0, which means that x is bigger than or equal to? As an interval, that is -4 to infinity, exactly. Okay, how about the domain of g? What has to be positive? The thing you're square rooting, right? And the thing you're square rooted is 3 minus x. So 3 is bigger than or equal to x by adding x to both sides. Does that make sense? That's the same thing as x is less than or equal to 3, right? So what is that as an interval? Okay, and if it helps you draw a picture, once you do more of these, you'll be able to do this mentally. So for f, you go from -4 everything on up, right? For g, you're at 3 everything on down. And from that pictorial representation, where are the numbers that would work in both?
-4 to 3.
-4 to 3, yep. So this guy's domain is -4 to 3. And if you've got some spare time and want to check if you're right, you could try plugging in numbers outside that interval and see that they don't work. Like if you plug in, say, 4, would 4 be okay in the first square root? Yes or no? Would it be okay in the second square root, though? No, because 3 minus 4 is -1. Okay, how about the next one? What's going to change? So it's f over g, right? So that's the same thing as root x plus 4 over root 3 minus x. So it's probably best written as one big old square root, x plus 4 over 3 minus x. So you find the domain the same way you find the domain of f, which we discovered was -4 to infinity, right? Domain of g was -infinity up to 3, right? And once again, you intersect them, but you've got to leave out any points where the denominator is 0. So what number makes this denominator 0? 3. So the domain of this function will be -4 up to 3, but do not include 3. Has to work in the top, in the bottom, and not be 0 in the bottom. Okay. How about this guy? So f of x is just x minus 1, and g of x is x minus 6 over x minus 1. So f times g. So take x minus 1 and multiply it by x minus 6 over x minus 1. That's what fg means. If I meant composition, what has to be in between the f and a g? What's the little circle thing? The o, exactly. Okay, now simplify this. Can you distribute the x minus 1, and that gives you x times x minus 1 minus, what happens when the x minus 1 distributes to that second term?
Denominator cancels.
The denominator cancels, just have 6. So that's x squared minus x minus 6. You don't have to factor anything unless you've been prompted to do so for some reason.
It's nice for finding domains.
It's nice for finding, well, it's nice for finding domains if the thing you're factoring is in a denominator, but in this case, that expression where it's 0, those numbers are still in the domain. Is everyone okay with the simplification and multiplying? Okay, now the domain's a bit tricky, only a little bit. What's the domain of f? F, sorry, you but you said for G is right. So the domain of f is all real numbers, right? Anything goes. The domain of G is just that x cannot equal 1. And even though that denominator canceled when you multiplied, you still have to leave the 1 out because this function came from doing f times G. That's a tricky bit with these domains. So you still have to look at, okay, where would these domains overlap? And since 1 isn't included in G's domain, it can't be included in the f times G's domain either. So this domain is minus infinity to 1, union 1 to infinity. I'm probably going to ask for all of your answers in interval notation just to make the grading easier for the grader and to make sure that you know it. But it's okay to do stuff like the x can't equal 1 in your work or if you're doing extra practice. Okay. Next we have fractions over fractions. So x minus 1 over x minus 6 over x minus 1. Okay, now it's kind of bad math grammar to have fractions and fractions. So what could you do to get rid of the fraction that's in the denominator? Multiply by x minus 1, exactly. So take this and multiply that whole expression by x minus 1. And if you do that on the major denominator, do that in the major numerator as well. Okay, so in your numerator you have x minus 1, the whole thing, squared, right? How about the denominator? You get x times x minus 1. That's when the x minus 1 distributes to the first piece. And then how about when it distributes to the second piece? Minus 6. Very good. So that's x minus 1 squared over x squared minus x minus 6. Is that okay? And now Cole was right. It is definitely easier to see your domains if you factor some things. So let's factor that thing in the bottom. How does that factor? Great, x plus 2, x minus 3. So either one of those is acceptable as your answer for whatever f over g is. And you can actually just look at this. You can at least tell me some stuff that x cannot equal at that stage. Does that make sense? What are a couple things x cannot equal there? -2 to 3. And there is one more number that you have to leave out.
1.
Yeah. Because in your original expression, you had a denominator that contained x minus 1. Does that make sense? Okay. So holy moly, what is that as an interval? So minus infinity was the first stopping point.
Wait.
Yeah, sorry.
Would you have to set the entire denominator at the beginning to 0 and find...
Setting the entire, that's a great question. If you set the entire denominator to 0, that's actually the same thing as solving this guy. So it's a really, really good question though. So if you have x minus 6 over x minus 1, you set that to 0, you're going to get x equals 6 over x minus 1, which is x times x minus 1 equals 6, which is the exact same thing you've got down there. Yep. That's a great question though, because that's also something to think about. Yep. Yep, okay, good. Okay, minus infinity to, what's the, -2, parenthesis, union -2, who's next?
To one.
To 1, 1 to,
3.
uh-huh,
Oh, I know.
and then 3 to infinity. Is there a pattern between the number of points you leave out and the number of little intervals you get? I'm pretty sure it's always one more. Does that make sense? If you leave out 1 point, you have 2 intervals, right? If you leave out 3 points, you have 1, 2, 3, 4 intervals, right? So just in case you want to be clear that you got them all. Okay, we good to go? Okay. All right, compositions. So given f of x equals root x minus 1 and g of x is x squared, find f of g. I'm going to put the little x there because it makes me feel better. F of g of x. So first, I think it's useful to translate that into f of g of x with parentheses instead of the circle. That is just what that means. It's just a definition. It's like this is an Apple Pencil definition. That is its name. All right, so f of, and g of x is x squared, right? And then you ask yourself a little bit, because this is the domains are what's tricky for these problems. Are there any numbers that you can't square? No. So at that point in time, you're all good. Any number is good, okay? Now you plug that x squared into x minus 1. So you get the square root of x squared minus 1. So at this stage, all x's are okay, and I want to say like okay in quotes because it's not like they're not okay in the end. They're okay just for squaring. Are all x's okay for this part now? Can you plug in 0, for example?
No.
No, you're going to get an imaginary number. So I think the best way to figure out the domains of those pieces is to graph them. So we're going to try to solve x squared minus 1 bigger than or equal to 0. The rules you know about square roots don't work because of the whole plus minus reversing inequality signs. So the way to graph this, the way to solve this is to take this, make it into y equals x squared minus 1 and draw a picture. That's a parabola, right? It's a very, very easy parabola to graph, isn't it? So it's a parabola that's been moved down 1, and it crosses the x-axis at plus or minus 1, right? So that's a graph of the thing that is being square rooted. And you can only square root positive numbers, right? So on that picture, where are all of the positive numbers? Before -1 and after 1, exactly. And also including -1 and positive 1, right? So the domain for this guy is minus infinity to -1 and 1 to infinity. Okay. How about this next one? We have other composition, g of f. So g of f of x. F of x is root x minus 1. And you stop and you pause and you ask yourself, at this stage, are there any numbers that I can't plug in? Oh, yeah, so you can't plug in anything that's less than 1, right? So for example, you could say, okay, well, x minus 1 has to be bigger than or equal to 0, right? Because I'm square rooting something, which means that x is bigger than or equal to 1, right? So at this stage, I only can plug in numbers from 1 to infinity, nothing lower. And then that root thing gets plugged into the squared thing, and I get root x minus 1 squared. And what happens to the square root sign? It goes away and you just get x minus 1. And the tricky thing is if you just look at x minus 1, you think the domain is all real numbers, right? Right, does that make sense? Because there's no restrictions there. But because your original function involved the square root, somehow you still have to account for that. You did that to the number first and then did the square root. Does that make sense? So you have to check that domain at the intermediary step. So this domain is 1 to infinity. So you must say, I think the good way to think about it is you must find the domain before you simplify. Does that make sense? Okay. And because I know we absolutely love fractions inside of other fractions, I thought we should do a couple of those. Just because they're tricky, and this simplification is a good thing to know for calc. So f of g of x. Okay. So g is equal to what?
2 minus 3x divided by x.
Great. And at that stage, let's just make a note that x cannot equal 0, right? Okay, now what happens to the 2 minus 3x over x? Where does it go?
The x place.
Of the,
F
Mhm.
x.
great. So that becomes 2 over, make your major fraction bar like totally obvious. 2 minus 3x over x plus 3. So this stuff went there. And you're like, gosh, that's ugly. Yes? Okay, so, well, we're just gonna finish it now. So it's a great trick to know how to multiply by something to make a denominator go away, right? Yes?
Since we know that it can't equal -3, can't we just set it to -3 too?
You could set it to -3 to figure out the rest of the domain. That's what Marky was asking earlier. I'm pretty sure that that's gonna yield the same result as simplifying and then looking at the answers domain. Like we showed with you, right? Okay, so multiply this by x, right? And to be fair, multiply the numerator by x too. And by be fair, I mean you multiply by 1. Multiplying by 1 doesn't change anything, right? That's the reason that that trick works. When you do that, what does the numerator become?
2 minus 3x plus 3x.
Numerator.
No, 2x.
Uh-huh. Denominator, you're right. What does the denominator become? 2 minus 3x plus 3.
X. Plus 3x.
3x, thank you. I knew something was wrong. Okay. So that's 2x over 2. So that equals
X.
x. So I kind of want to double check something, but I'm pretty sure that since this denominator is simplified to 2 and is never 0, there's no more additional restrictions. But I want to check it by setting 2 minus 3x over x plus 3 equal to 0 and just see what happens. 2 minus 3x over x equals negative, like Tyler was saying, right? 2 minus 3x equals negative 3x, right? And you get 2 equals 0. Does that make sense? And this means that this equation has no solution, which means that there are no more numbers making that denominator 0, and it is consistent with the result of us getting a 2. Okay. All right, so that simplified 2x. Beautiful. Are you okay with the whole messing with fractions business? Okay, so let's try the other direction, g of f. And with compositions, order does matter. It's an example of a non-commutative operation like subtraction and division where order is important. So in general, when you switch the order, the compositions won't be the same thing. Okay, so that's g of 2 over x plus 3, plugging in what f is. And then how many spots does the 2 over x plus 3 go in the other function? Twice, yep, exactly. So 2 minus 3 times 2 over x plus 3 over 2 over x plus 3.
That's an ugly fraction.
That is an ugly fraction. There is a good way to deal with it. There are actually multiple ways to deal with it, but I'll show you the one that I think is the best. So first, does it make sense if I'd say 2 minus 6 over x plus 3 divided by 2 over x plus 3? Just multiplying that 3 in front of that second fraction really is 3 over 1, so. Okay, now I can think of two ways to proceed. You could get a common denominator with that 2. Does that make sense? And then you could reciprocate the major denominator. Is that idea okay? I think that's the thing that would come to you most naturally, and it's a great method, it'll work, it's just a little bit more tedious. An easier thing to do is to use the whole multiply by something that'll make stuff cancel for you trick. So what will we multiply by to make the denominator in the denominator cancel? And also the same thing in the numerator, right? If it makes you feel better, you could technically think, okay, well, it's x plus 3 over 1 and x plus 3 over 1 in both places. Okay, now that x plus 3 is going to distribute. So when it distributes to the 2, does it cancel? No, so that's 2 times x plus 3. When it distributes to the 6 over x plus 3, does it cancel?
Yeah.
Yes. Okay, how about in your denominator? What do you have there?
1,
No,
2.
almost 2. You're right about it being a constant. Okay, so that's 2x plus 6 minus 6 over 2. So, we get 2x plus 2x over 2 again, don't we? Which is just x. Does that make sense?
So these are inverse functions.
Yeah, we're going to talk about inverse functions tomorrow and on Thursday. But when you do this composition in both directions and they both give you back x, those are special functions called inverses. We didn't specify the domain here, and we really should. X cannot equal, there's nothing in the end that is giving you an issue, but there is a number in the beginning that is a problem. -3, yep. So negative infinity to -3, union -3 to infinity.
What about 0?
What about 0? Oh, see, 0 isn't a problem because you change the number that's a problem here. So instead of looking for where that's 0, you'd have to look where 2 over x plus 3 equals 0. Does that make sense? That's going to be the same thing that happened with the last number. Well, numbers last time you try to solve that, multiply both sides by x plus 3, you get 2 equals 0, which means that expression is never 0, and so it doesn't introduce any new numbers. Yeah, so 0 isn't a problem because the thing that you plugged into the denominator, you'd be setting that thing equal to 0 now instead. And the restrictions you'd get after simplification are the same ones you'd get by taking this thing in the bottom and setting it to 0.
That makes
Now, that's tricky, but that makes sense. And since we got a 2, that's never 0. It might even be the case that if this simplifies to 2, you're always going to get like a 0 equals 2 kind of equation as well. Yeah. Okay. But yeah, those are inverse functions. Now, and also it was the case that the order in this example produced the same result, right? Different orders produce the same result. Okay. That happens with inverses all the time. With these functions, it also is the case that the compositions are going to be the same thing. but the domains are gonna be a little bit different. Okay, so f of g of x. So that's f of g of x, which is f parenthesis square root x squared plus 25. Say that again?
Isn't that just x plus 5, or can we not do that?
You can't do that. Yeah. I will, when I finish the example, I'll explain why it's not true, okay? Because it's a common mistake and I need to fix it. Yep. Okay, is everyone okay with at least plugging in g of x there? Okay, now let's look at the domain of this g of x function. So you could do it like looking at a parabola, like a graph of it. You want to solve x squared plus 25 bigger than or equal to 0. If you graphed y equals x squared plus 25, what does it look like, roughly speaking? It's a u shifted
25
up 25. Like, don't draw 25 tick marks, okay? That's not your job. Look, there's 25. So are those y values of that expression, are they ever negative?
No.
No. The smallest they ever get is 25, right? So that means that you can plug any number you want to into this expression. So the domain of the x squared plus 25 is all real numbers. Or you could say here, the domain is R for reals. Sorry, totally bad habit. I used to use ARN for a symbol until I realized that nobody else did that. So. Okay, so reals. All right. Okay, now proceed and plug the root into the f function. So you've got big old square root, parenthesis, square root x squared plus 25, that whole thing squared, minus 9. What happens when you square that square root? Cancels, and we get the square root of x squared plus 25 minus 9, right? Which simplifies to root what?
No, 16.
X squared
Plus 16.
plus 16, there we go. Great trick. Take away 10 and then add 1. Does that make sense why that would work? Okay. Okay, so root x squared plus 16. And just like before, you look at the domain of the thing you plug in, then the domain of the thing you get once simplified. So if I were to graph x squared, y equals x squared plus 16, it's a parabola shifted up 16, right? Are there any numbers you can't plug into that? No. So this thing is going to have domain all real numbers as well. If it would have come out to be x squared minus 16, then you would have had a restricted domain. Okay, quick aside, because Tyler asked a great question that's a really, really common mistake. So true/false, write this down because it is something that sometimes when you encounter harder problems, you make up rules that are not true. So is root a plus b equal to square root a plus square root b? What you're trying to say there is that that square root can distribute. So, for example, is root x squared plus 25, is that equal to root x squared plus root 25, or x plus 5? That is false. And the reason it's false is it doesn't work for every single pair of numbers. And the example that's super nice is, let me see if I can come up with it on the fly. I think it's 16 and 9. So you learned in probably like algebra 1 that the square root sign kind of acts like a parenthesis, and you're supposed to do the stuff inside of it first before you root. So following that, you get root 25, and that gives you 5, right? And if you like conjecture, well, maybe this equals root 16 plus root 9, which would equal 4 plus 3, which is 7. And since it doesn't, the like conjecturing step, like of saying, oh, maybe that's what that was, is not true. Yeah, so that is definitely false. What if I gave you 1 over a plus b? Is that equal to 1 over a plus 1 over b? Okay, let's try some numbers. 1 over 1 plus 1 equals 1 over 1 plus 1 over 1. True. You want to revise your answers? Okay, so true or false? False. Does that make sense? I have a rather ranty packet that a calculus teacher, I think it must have been a high school teacher, wrote about all the stuff students do wrong that they should know. But at the end, once we get to more stuff, we have some time, I'll show it to you, and we'll go through like why all these things are not true. Those are 2 of the things that are on there. So, it's a great question. I'm glad you asked it. Okay, let's try the other composition now. So g of f So g of root x squared minus 9. So at that stage, are there problems in your domain?
Yes.
Yes. If you were to graph x squared minus 9, it's a parabola shifted down how many? 9. Where does it cross the x-axis?
Negative 3
-3
here.
and 3. Okay. So at that stage, what numbers can be included?
Anything less than 3 and anything greater than 3.
Anything less than -3, yep, and anything greater than 3. So negative infinity to -3 and 3 to infinity. The numbers in between -3 and 3, non-inclusive, cannot be put into that root x squared minus 9 function. Okay, so that becomes square root of square root x squared minus 9 squared plus 25, because that gets stuck into the g. Is the result in the end, does it appear to be different than the result we got for the previous problem? No. It's root x squared plus 16. The only difference is you do have to say the domain is negative infinity to -3 union 3 to infinity. That's the only difference, is you have to be careful about what the domain is, because technically you're plugging that number into the root x squared minus 9 first, and then doing something to the result that you get. And if you can't plug the number into the root x squared minus 9, you can't plug it into the end number as well, even though the functions simplify to the same thing. So that's definitely very technical. Okay. Alrighty. Okay, so for these, we're going to find f of g and g of f, and then we're going to sketch the graphs of f and g on the same coordinate system. Some special things are going to happen here. So f of g of x, that'll be f of g of x. So f of in for g goes 1/3 x minus 2/3. So that's 3 times 1/3 x minus 2/3 plus 2. Does that make sense? Okay, now when that 3 distributes, what do you get? X, right? What comes next? Plus, which gives you x. Okay, so one composition is x. Try the other one. Like, you try now. What'd you get out?
X.
X again. It looked a little bit different in the middle steps, right? Does that make sense? But you still got out X. Now the last part of the question, I think I gave you a grid there, right? And I said sketch them both on the same grid. So if you're ahead, go ahead and start sketching. If you have a question, ask me. Daniel, did you have a question? No, you got it? Okay, where does f of x start? At what number on the y-axis? 2. And then it rises 3 and it runs 1, right? Or goes down 3 and backwards 1. It's just a line, no freaking out necessary, right? Okay, I know it's imperfect, but where does the other one start on the y-axis? So approximately right there, right-ish. And then from there you go up
1,
and over,
3.
so up 1, 1, 2, 3, up 1, 1, 2, 3, down 1, 1, 2, 3. Does there, okay, so there's the pictures of f and g. And these functions are special things called inverses. We'll talk more about them tomorrow, but does there appear to be any special relationship between those two pictures? They're flipped over the line that I just drew, which is the diagonal. So that if you were to finger paint in one line, fold your paper in half along the diagonal, you're gonna get, and then you get the other one, right? Okay, that will always be true if you have these two compositions giving you back x. Okay, try the next compositions, okay, because they're also pretty easy. So find f of g, find g of f, and then we'll sketch the pictures. Did you get x for f of g? Okay, I'll just do g of f on the same slide so you can look at them both. G of f, g of f of x. So that's g of the cube root, which gives you the cube root x minus 2 cubed, or x minus 2 plus 2. Did you get x in both directions? Okay. If I ask for questions like this on a quiz, you have to show me your steps. Does that make sense? Because don't do it all in your head, like leave me a step where you plug something and then like show me the first thing that cancels and then the next thing. Does that idea make sense? Okay, just so I know. Okay, so both gave you x, and we're gonna see if that whole reflection across the diagonal thing is still true. So do you remember what x cubed looks like? It's kind of like an S, great. So this is not the final answer. It goes through 0, 0, 1, 1, negative 1, 1. And when you plug in 2, what does the cubed give you?
10.
8. I haven't moved it up yet, so you're right about the whole when you've added 2. Does that make sense? So I'm going to take those points that I drew and I'm going to shift them up 2. Does that make sense? And just draw the ones that fit on the grid. So the one that's at 10, no big deal. But 1 will be at 3, 1 will be at 2, 1 will be with positive 1, and then 1, 2 down there. So you're right, it is kind of S-shaped-ish. Okay. How about this cube root function? That goes through these same 3 points, doesn't it? But it also goes through 8, 2, and -8, -2. Does that make sense? So that's the cube root of x function. And then since you have cube root of x minus 2, that's a shift left or right. And how much and in which direction? To the right 2, exactly. So take those points and move them over to the right, 1, 2. And just draw the ones that fit in the grid. And give it the approximately correct shape. And I'll draw them in a little bit thicker so you can really see. Does there appear to be that whole reflecting pattern going on here as well? Yeah, it's even a little bit more obvious, isn't it? Okay, so there's your pictures. Okay, good to go? All right. Okay, so this idea comes up in calculus when you do something with this thing called the chain rule for finding derivatives. So you have to be able to tell which function has been put inside of the other one. So you have some function h of x, and h of x came from doing f of g of x. And you think about g as the function that's being put inside of f. So what I want you to do is look at this thing that's been composed and tell me what was f and what was g. So there is this 3 minus 5x, right? And it's inside of a 7th power, right? So we're having g being put into f. So who is the inside function? G, the 3 minus 5x, that's the inside function. And it's inside of something to the 7th power, right? It's inside of x to the 7th. They should be really easy once you get the pattern. And if you're uncertain, just check. Find f of g of x. It's f of g of x, which is f of 3 minus 5x, right? Or 3 minus 5x to the 7th. Okay, so you're trying to like say, okay, what two things were put together? How about this one? So we have g of x and f of x. So g is the inside function, right? In this case, who's inside? And what is 3x minus 11 inside of? X raised to the 1/2 or square root x, either way. It actually is often better in calculus to think about that as x to the 1/2 powers. That's a perfectly legitimate answer. And you could check by doing the composition, find f of g, and you'll get the same thing back. Okay, how about this one? So f of x is not as obvious, but I think that you could think about this as an x to the 6th being put inside something else. Does that make sense? So the g function is the x to the 6th, and what was that stuck inside of? 5x plus 3. It was stuck inside of a line. So you replace the x by x to the 6th.
Is it okay if I have g of x being 5x and 6?
G of x, if you have g of x be 5x to the 6th, what did you make your f?
X plus 3.
That's also correct. Yep. There's more, yes, uh-huh.
So, yeah, just along the lines of that, last semester, my teacher said that we weren't allowed to do the simple forms like that, like we had to make them complex. Are you moving
I don't think that there is a simpler. I think what she was referring to specifically, this is my guess. I think she was referring specifically to that you couldn't let f of x just be x. Does that make sense?
Yeah.
As in, I think that's what she meant, because then you could always do it that way. You could always say, oh, well, f of x is x and g of x is 5x to the 6 plus 3. That's probably what she meant. If you said x plus 3, I think that's not simple enough. And often this does not come up in quite this context. It's more often the context with stuff like you're going to have cosine of 5x squared plus 1. And so, but I would say specifically you cannot let one function equal x. That's not okay. But if it's x plus 3, it's technically correct, and I think it's also fine. Okay, how about this function? So f of x, g of x. So a root x got stuck in a denominator, right? Does that make sense? So I'm going to say that, well, g of x is root x. And if I do that, what was the root x stuck inside of? Negative 2 over x plus 1. Yep, okay. So that idea of like thinking about what two things were composed will come up in calc. So just FYI. Okay, and in 10 minutes, we're going to do 3-word problems. You ready? Yeah, I know. Okay, so economics, because we should understand economics. So the demand, X, and the price, P in dollars, for portable iPod speakers, because you guys are going to work with iPod speakers, at an electronics store related by this equation. So X would be how many units sold as a function of what the price is. You sell more if you charge less, right? Okay. And this function tells the revenue, which is how much money you have at the end of the day before you factored out your costs. Does that make sense? And this C of X equation, that tells you how much it costs you to produce these iPod speakers. So express the profit as a function of the price P and find the price that produces the largest profit. So if revenue is how much money is in your drawer at the end of the day and cost is how much you're spending, how would you figure out profit? Take the cost from the revenue. So I'm going to call it capital P of X. You have those things in your papers, you'll be able to look at them. Capital P of X will equal R of X minus C of X. So that'll be 50x minus 1 over 100x squared minus the quantity 20x plus 40,000. Which simplifies slightly to negative 1 over 100 x squared plus 30x minus 40,000. Does that make sense? Because the negative distributed, so I did 50 minus 20 is 30, right? Okay, so there is your profit function. And notice that the x in this profit function, x is how many things you're sold, it's your demand, like how many iPod speakers. What this textbook wants you to do, you know that x equals 5,000 minus 100p. Does that make sense? They want you to express this profit as a function of the price, which means they want you to take this thing and stick it in for all the x's. Does that make sense? So negative 1 over 100, 5,000 minus 100p squared plus 30 times 5,000 minus 100p minus 40,000. Now, simplifying that's gonna be a pain. I don't know if Alex will make you do it or not, and if they don't bother, because there's a better way to solve the rest of the problem. But the part that says as a function of the, God, I said I wrote prive and not price, oh my goodness, of the price, means your end equation has to have the price variable in it. Okay. And the second part of the question says to express the profit as a function of the price, find the price that produces the largest profit. So I think the better way to answer that last part of the question
The vertex.
is to find the vertex. And I think it's best to find the vertex of this guy. Does that make sense? Because you could find the vertex of this thing after you've simplified. It's gonna be a huge pain in the butt to simplify that way. You're probably gonna make a mistake, right? I would. So, and how do you know that so this, if you were to graph that thing that I starred, would it be a happy or sad parabola?
Sad.
It'd be sad. So it has a highest point, and the highest point is the vertex, right? So you can find it using the negative b over 2a formula, right? You say, well, okay, x equals negative b over 2a. So that's negative 30 over 2 times negative 1 over 100, which is negative 30 over negative 0.02, which if you have a calculator gives you 1,500 units. That's not your answer. It's kind of like almost there. It is X. So this tells you how many things you would sell at that best price. How would you figure out what to make that price? Reverse engineer by putting this into that equation. So put this into that, and you've got 1,500 equals 5,000 minus 100p. So take away 5,000, that gives you negative 3,500 equals negative 100p. And so p will equal how much? Cancel 2 zeros when you divide, right? 35. So the best price to set it at is $35. I'm just concerned that because Alex follows your book, it's going to want this equation with the p's in it. Does that make sense? Like, as that, you're going to have to give it that answer to be correct. But I think it's best to find the vertex of the one where you haven't plugged that in yet, and then get the answer. Just keep track of what variable that you have. We can do example 11 because it's actually quite short. We'll get to example 12 on next time. Okay, this kind of question has been calculus as well. I chose these word problems on purpose because you'll see things like this quite similar again. So a weather balloon is rising vertically. So you got some balloon going up. An observer is standing on the ground 100 meters away. Express the distance between the balloon and the observer. So in math, distance always means straight line, as a function of the height above the ground. So how can you relate d, h, and 100? Do the just Pythagorean theorem, then you're going to square root it. Yep, so d squared will equal h squared plus 100 squared. What is 100 squared? 1 followed by how many zeros?
10,000.
4, yep, 10,000. And so d equals technically plus or minus the square root of h squared plus 10,000. But do you ever have negative square roots when you're talking about distances? No, so it's just the distance is positive square root h squared plus 10,000. Yeah.
So it says you have to, as a function of the balloon's distance h above the ground, does that mean it has to be h instead of b?
No, so f is f is a function of x means x is your variable. Or if you say express y as a function of x, that means the function of is the thing that's inside. That's just vocabulary though, but yeah. So if you say distance as a function of height, the height is the x, the distance is the y. And you can think like y is a function of x. Okay, last part of that problem says, if the balloon's distance above the ground after t seconds is given by h equals 5t, express the distance between the balloon and the observer as a function of t. So we know d equals the square root of h squared plus 10,000, right? And we want to express it as a function of t instead. So can't we plug in what h is equal to in terms of t? So that will be the square root of quantity 5t. The whole thing has to get squared. What happens to the whole thing when you square it? What does it become? And because I think it will make stuff easier to work with, that can be simplified a little bit if you factor out the 25. So 10,000 divided by 25 is 400. And then what can happen to that 25? It can get rooted and it can become just a regular 5, right? And so this equation would allow you to plug in a particular time and figure out how high up in the air that balloon was at that time.